Yo, T-Bone Knuckles. What's good, dude? Yeah, no.
That's dope.
What's up, dog? All right. Let's get you that point already for joining. Ooh, Hyper Yoshi's in, dude. What's up, Hyper? Yo, what's up, Danny Yoshi?
What's up?
Yo, is this Danny Yoshi 3, 4, 5, 6, or 7, dude?
The first ever created?
The first ever created, dude. He's like,
That's dope.
Let's get it, dude. For the OG Danny Yoshi. I think you still have actually a couple accounts that are working.
I actually don't know.
I see like 6 and 8 is still following me, so you haven't gotten those banned yet. Yeah, he's like, yeah. Nice. Are you are you watching the Twitch stream, Danny Yoshi?
Yeah, I'm in the stream now.
Oh, nice. So just hit if you use the command !point here, that's how like nice. That's how it yo what's up, medic? That's how it counts the attendance, so I can give you guys points for hopping on today's office hours. Let me add this guys real quick.
Okay, Gio,
What's up,
I missed some
Sword,
time
dude?
from my schedule.
What's up?
Yeah, I can't hear Gio that good. What the heck?
You can't hear me? What do you mean you can't hear me?
It's like you're really low, your voice.
Am I? On what? On what? All right, one sec. On the Twitch or on Discord?
On Discord.
Really?
Nice.
Oh, yo, Danny Yoshi's a follower, dude. Nice, dude. We got the OG Danny Yoshi. Oh, maybe my voice is quiet on the stream. I think that may be what it is. But it's Danny Yoshi. Can you hear me in the Discord?
Yeah.
You can? Yeah.
Yeah.
Nice. So Bomby Boy's rating, dude. What's up?
Voting has commenced.
Okay, Gio, I realized if I get 8,000
Wow.
bonds.
Oh, what's up,
Bond
T-Bone? Yo,
points,
thanks for the
bond
host, dude.
channel
T-Bone,
points.
awesome. Sorry, what'd you say, Sor?
If I get 8,000 bond points, like on his stream, right?
Yeah.
I'll get 4 more, so I can get 1,100 card points.
Oh, wow. Nice, dude. Yeah, Bomby Boy just set up. So we're setting up also streamer rewards on the Bomby Boy stream, so that if you watch and play games with us, oh wow, yo, and Soar's also hosting. Nice. You also can get bond coins that way, which you can redeem for COD points and all sorts of fun prizes and stuff, dude. Yeah. He says, nice, dude. Okay. All right. So
Learning and gaming at the same time. Perfection.
sorry. What?
Hey, I see Gio the new layout.
You like the new
All
layout?
golden. Haha.
Yeah.
That golden life.
that golden life. That gold life. Yeah. Nice. Danny Yoshi with the attendance stuff, dude. Let me add you in real quick.
Will be our subject for this.
Well, T-Bone Knuckles has actually provided a
Nice.
question for sale. What's up, Surge Rise? Yo, thanks, dude. Thanks for the follow. T-Bone
Oh,
Knuckles
yeah.
has provided a question that we're going to go over. And then if you guys have any other ones, you are encouraged to, come up with something. I know school is ending for a lot of students right now, so you can also talk about something maybe you learned in math this year that you're like, that didn't make any sense to me, or something in science where you're like, well, I didn't get that. And we can also go over that. Okay, so here, let me pull in. I'll add all the bond coins at the end. This is it would take me a lot of time to do that. Let's pull in T-Bone or Knuckles, dude, with the question about parent functions and child graphs. Parent graphs and child graphs. Let's see. There we go. Danny Yoshi, what grade are you in again, dude? You're like 16 or something, right?
I'm 13.
Oh, 13. Okay. So you haven't really done graphing things yet, have you? Like graphing functions and
Nope.
stuff. Nope. Okay. Cool. All right.
Done none.
But you've oh yo, what's up, comrade, dude? Comrade's in, dude.
Oh,
Red Inkling, dude. Nice. So yeah, so this is here. We have a question here that T-Boner has posted in the office hours, and it's about how to graph something and then compare it to something else that you want to graph that looks slightly different. Okay. So for those of you that are just joining us today, and so we started going over this actually in Wednesday's office hours. We showed how to graph functions. Graph something and then compare it to something else that you want to graph that looks slightly different. Exactly, dude. Here, let me boost your volume, dude. Your volume's kind of, Danny Yoshi, your volume's kind of low. Let me boost it. There we go. Yeah, so exactly what we did. So we had, for instance, here was like, here was a graph that we had. Actually, it wasn't this one. Where is it? Yeah, 1 sec. Let me move it over. Yeah, here we go. This was a graph, for example, y equals x squared. And a way to graph these things is to make a little table here where you pick out what the x points are and what the y points are. So a graph looks something like this, where this is what we call the x-axis, and this is the y-axis. And usually we label this with numbers, like this is 1, this is 2, 3, and so what. And this is another axis, 1, 2, 3. You guys have probably seen graphs. Do any of you guys, what's that tracker everyone uses for COD, dude? What's it called? WC stats or something? Or
COD Tracker.
is it COD Tracker?
I
Or
don't
is it
know.
WZ Ranked, dude? Is that what it is? This thing, right? Has anyone ever used this before? WZ Ranked? Let me see. It's actually really cool. So this is, for instance, these are my stats for playing Warzone, which, they're not the best stats. But this is an example of a graph.
Wait, I want to see my stats.
You want to see your
What's my
stats?
stats?
Yeah, what are your stats, dude? What's your username, dude? Let's pull you up. Do you remember your BattleNet?
I don't know. Let's go to PlayStation.
Sure, we can do PlayStation. That's cool. Yeah, let's do PlayStation. What's your PlayStation username?
And it's put my COD user tag.
Well, I don't know what your
The
COD user
exact
tag
same
is.
way.
You got to tell me what your COD
It's
user tag
literally
is.
the Twitch. It's my Twitch.
Oh, so
name.
is it not unsore? Is it that?
Yeah, like it's like spelled like that too.
Just like that?
Yeah.
Okay, let's check. Let's see if it has stats for you. Okay, cool. All right, so here's Soar's data, dude. And what we have here, these are examples of graphs. So, 1 second, let me change this audio a little bit.
Damn, I can't even drop it.
Yeah. Move my window over. Oh, it's crowding in the chat. Oh, interesting. Yeah, you're right. Well, yeah, that's something for next time. I'll fix that next time. Actually, I think I can do that with just chatting. No, we did this one. Yeah, little growing pains as we figure out OBS. But okay, for now, guys, this is an example of a graph. And here, let me just snap this real quick so we can look at, for instance, Soar's KD ratio over the matches that he's played. So okay, let's pop it. Okay. So this is an example, guys, of a graph where it has 2 axes, right? This is what we're going to call the y-axis, and this is the x-axis. Here. And what this is useful for is you can use this to show how data changes over time. So an example here with KD ratio, you can see that on the x-axis here we have the number of matches played. So for instance, when Soar has played 3 matches, which is the x point, you can check what his KD ratio, which is the y-axis here, and we can see that it's about 1.2. So in the first 3 matches that Soar was playing, he was a pretty good player, dude. 1.2. And then he started playing a little bit with DM2. DM2 started hogging all the kills, right? Because he's a sweaty rose skin, and his KD started going down a little bit. And we can see that because as X, the number of matches played, goes up here, his KD ratio Y starts to go down. Not TM2. He's like, no, I'm not playing with TM2. Yeah, I know. But anyways, So this is for everyone who's wondering like why graphs are useful. This is an example. This is a graph. It turns out that this graph is a bunch of points. For instance, at very specific, like at this match he has this KD, this match he has this KD. But a cool thing in math is what we can do is we could model this trend or predict this trend with a function. So a function, for instance, could look something like this. Let's say the function is equal to 1 over x, okay? Or actually, let's say it's equal to, let's say it's 2 over, let me think, what do I want to make this? Yeah, let's just say it's like 2 over x. So what happens is, if we had a chart here, where this was y and this is x, what would happen if let's plug in some values here real quick. Actually, let's make this x and y. So if I plug in x equals 1, what is y going to equal if y is equal to 2 over x? Does anybody know? Happy Yoshi, you saying something? Let me boost your volume.
Well,
So here we're looking at a function here, and I'm saying that the function follows an equation, which is y is equal to 2 over x. And what I'm saying is we're going to try to see. Sorry. Someone said something real quick. No, I didn't hear it. Okay. We're going to try and graph what this function looks like, and doing that means plugging in values of x to see what y is. So if I look at when x is equal to 1, that means all you got to do is you just got to replace this with a 1, which means this is going to equal 2 over 1, which is just 2. Okay? So that means when x equals 1, y is equal to 2. Good. Good. Yeah. Okay. So now, let's see what would happen if we plugged in another x value. Let's say we plugged in x is equal to 4. If I plug x is equal to 4 into here, what do we get for y? Yeah, good surge vibes, dude. Nice job with the 2. That's good. Yeah. But let's see. Let's put in 4. What would happen if we plugged in x equals 4? Good, good, good. Very good, Surge. Yes, yes, dude. 2 over 4 or 1/2. Exactly. So now if I plug in x equals 4, I get this is equal to a half. So what I could do here, right, is I could take this function and I could graph it. And so, for instance, when x equals 1, which is right here, the value would be 2. Okay? When x is equal to 4, which is somewhere around here, this value is now a half. So that would be like down here. And then we could keep doing this for more and more values. Why do we have gym class? We have gym class in case recess gets full. You know, recess is where we play Warzone after studying. Usually this is going to be hosted on Bomby Boy's channel, but if Bomby Boy's unavailable to do that, we'll host it here on this Discord. And I'm foreseeing that we'll have more than 4 people for quads, so it helps to have more channels that we can build stuff out. No, nobody is fat. No, I'm not calling anyone fat. Bomby Boy sounds cool, yeah, dude. Bomby Boy 1, sorry. Yeah, Bomby Boy 1. I always get that wrong. Okay. So, and then if we plugged in 6, we would get like a third. So that would be like way down here, right? A third isn't even on the scale right here. A third's like really bad. So this is an example of a function which, if you plotted more and more points for it, would look something like a curve. And this is useful because that allows you to predict things further on. You know, if this graph, if this function looks something like this, for instance, we could predict what Soar's KD would be out when he's played like 60 games. You know, so that's why graphs are cool, and that's what we do with functions. Okay. So the question here that T-Bone brought up is now taking a function and then graphing what we call a transformation to that function, which means that basically this line right here has been changed in some way. This could mean that, for instance, this line is moved up. You know, maybe Sword just starts drinking a ton of G Fuel, you know? And so we predict that, you know, his KD won't drop as much. You could also flip it. It could start doing this. And I'll show you how that would work. That, you know, maybe Sword gets a PC finally, and he starts really killing it in Rebirth, you know? Yeah, your KD's about to go up and down, yeah, nice. These are called transformations to the function. So let's look at what one of these would look like. All right. So, here we have the graph. F of x is equal to the cubed root of x. Okay. This is actually kind of a weird one. A lot of times you guys have seen what the square root of x is, right? Does everyone know what, like, the square root, like, for instance, if I said, like, the square root of 9, what would that be equal to? Dun. Three, dude, nice. Yes, good, perfect, good. Yes, exactly. So that's what we call, like, the square root of 9. This would be equal to 3. So a lot of times, so you don't need this 2 here, honestly, to write square root. Whenever they do this, this means just square root, which all square root means is what times itself will give me 9. And 3 times itself is what gives me 9. So that's why the square root of 9 is equal to 3. So now what we have is the cubed root of something. So what do people think the cubed root of something means? If the square root means what times itself equals a number, what would the cubed root mean? Pardon? Yo, what's up, Devin, dude?
What's up?
What's up, dude? We were just going over graphs and cube roots. Do you know what you know what a square root is, Devin, right?
Yeah.
Right, cool. So do you know what a cubed root is?
Never heard of it.
Never heard of it. Okay, all good, dude. All good. So, in your own words, what is a square root? Like, what does a square root do? If, like, say we did the square root of 4, like, what does that mean?
They multiply?
Good. Yeah, you're asking yourself what multiplied by itself. So what multiplied twice equals 4? Which in that case would be 2. What would, for instance, be like the square root of 16?
Say that again.
If someone asked you what the square root of 16 was, what would that be? 8? Danny?
256.
Okay. So, okay. Yeah, so you're thinking 16 squared, right? That's 256, yeah. The square root of 16 is kind of the opposite. So 16 squared means, yes, 16 multiplied by itself twice. The square root of 16 is asking you, what multiplied by itself twice gives me 16? Yeah. Does that make a little bit more sense? So what multiplied by itself twice gets you 16? Danny Yoshi said 8, which is, it's close, Danny Yoshi. Danny Yoshi, 8 is close. That would be 8 times 2 is equal to 16. It turns out that the thing that's multiplied by itself twice that gets you 16 is going to be 4, okay? 4 times 4 gets you 16. So that's why the square root of 16 is equal to 4. You're trying to find what number. Yeah, good. Nice job, Sir Drives. Yeah, Sor, yeah, 4. Yeah, 4 times 4 is 16. You should know that, right, Sor? Yeah, Danny Yoshi. All good, dude. Yeah. You did. I see what you did. You did 8 plus 8 is what you did. Yeah. We want to do 8 times 8, which that would be. So Danny Yoshi would have this correct. If we asked for the square root of 64, Danny Yoshi, what would that be equal to? Eight. Good. Nice. Exactly. Yeah. Because this is 64 is equal to 8 times 8. Yeah. Oh look. Look. Oh yeah. All good. Yeah. So here, let me clear this onto another page so we make things a little bit more clear. Okay. So now that you guys have a little bit of an idea of what a square root is, let's look at what a cubed root is. Okay. So I'll give you guys a little bit of an example. So the cubed root, for instance, of 8 is asking yourself, what times what gets you 8? Sora, you can raise your voice in the voice channel, dude, and ask me why you don't get it. I'm here to help. Don't be shy. Sora, what do you not get about square roots and cube roots? 2. Good. Yeah, Danny, Yoshi got this one right. Yeah, good. This is 2 times 2 times 2. So Sora, look for example here. If we have the whatever root, so here let's use. I love colors. Do you guys like colors? I fucking love colors. Can anyone guess what my favorite color is?
Green.
Good.
There you go. It's gold. Green is actually a cool color. Actually, before gold, I really liked blue, but gold is my favorite color.
What kind of blue color though?
I like a sky blue. Sky blue's nice. Like
Okay.
if I could pick out, let's see like a type of blue. Yeah, like this, dude. This is my favorite type of blue, dude. But here, Soar. So this is an example of how this works, how square roots, cube roots, and whatever things work. Okay. So when you have like some number here, right, and then you have this is called a radical. Is what this is called. I know you guys are pretty radical in the AO. You know, Soar's always running those hot drops. Can we have art class? Yeah, we probably could do art. You know, I like art. Yeah. Soar, if you want to do the thing, right? Remember last time you drew like a Charmander or something, and then I colored it in. Yeah, I should have like an art submission thing, but okay, guys. So if you have something that looks like this, a radical, and you have a number up here, and then you have a number inside here, what this is asking you is what times itself this many times. Okay. So this is like
She's being tossed too.
this is like the number of these. The number of multiplies, basically, is equal to the thing in the green. Okay? So does that make more sense?
It makes a little more sense now.
Makes a little bit more sense. Okay. So here, let's have you just work through one real quick. Then I promise I won't bug you for a little bit. Okay. But if we have, for instance, the let's say the third root of 27. Okay. How would I set this up to try and figure out what this is?
You said we had to find 27, right?
Good, exactly. Yeah. So here you can put the equals 27 over here, okay? Then what do I need to do here? Like what did I do here? What was here?
Find a total that equals 27.
You got to find the total multiple thing, the thing that multiplies itself 3 times, okay? So something times something times something that equals 27. That's where this comes from.
Is it 9?
Close. Wait, that's the wrong one. There we go. That's the one. It's close. Close to 9. What? So 9 times 9 times 9 is what? That's 9 plus 9 plus 9, right?
Oh,
Yeah, 9 plus 9 plus 9. That equals 27. But this means multiply.
it's 3.
It's 3. Nice, dude. Very good. Awesome, dude. Yeah. Great. Yes. 3 times 3. Good. Good job, Sir Revives too. Yeah, Danny Yoshi. Yeah. See, Danny Yoshi, I see a common thing where you keep thinking you need to add them. You need to multiply them all by each other. But yes, this is 3, because 3 times 3, right, is 9. Times 3 again is going to equal 27. Okay? All right, good. So, guys, pay attention to that, because there will probably be an extra credit question related to this. So it's always good to, like, pay attention and really, like, if something doesn't make sense to you, ask me. Sora brought it up. He's like, "Oh, I don't get this," and I'm like, "Cool. It's okay if you don't get stuff. Like, don't worry. Like, no one's gonna call you stupid. I'm not gonna call you stupid. Like, I'm stupid more often than most people, but the whole point is to make sure that you understand it, and then when you really understand it, that'll help you in life. It'll help you in math, but in day-to-day stuff right now, it'll help you get the extra credit questions right. And if you get those right, you get an extra bond coin, which when you get 10, we buy you a battle pass worth 1,100 COD points. There are a couple people that are pretty close. Yeah, thanks, T-Bone. Yeah. Well, okay, yeah. Again, this is no disrespect to your teacher, but teachers honestly have a very brutal job in that they are not paid very much, and they have to teach a concept to 30 students all at once. And a lot of times what that means is they need to find one way that the most people will learn it. But there's always going to be students, for instance, who don't really, they don't get it that way, or they need another explanation. And because a teacher, only has so much time, they have to just run with it. They just got to go with, like, what the best strat is, like it's like when your boy in Rebirth is like, "Yeah, no, dude, I can't res you, dude. I got to go for the win." That's why you guys don't get the best education from your teacher. But that's what we're trying to do. We're trying to help you. So by tuning in and whatnot, asking questions, we can help make sure that you guys understand this, and you get cool COD points. You can go buy all the dope skins and stuff. Okay. So anyways, so that's cubed roots and square roots. So now that we understand how a cubed root works, right? Because that's the first thing. If someone gave you this graph and you're like, "Shit, I don't even know what this means," right? This looks like some, like, hieroglyphics and like what's happening here. This is the first step, is figuring out what a cube root is. So now that we know what it is, now we can try to look at what the graph of the cube root of x looks like. Yes, good, Danny Yoshi. Yeah, remember, cube roots, you got to multiply. You don't want to add them. Okay. All right, and then here, let me move this so I can see my audio. I have a new mic coming in soon that hopefully will fix my issues of I move around too much. Okay. All right. So we're looking at what the cubed root of x is, okay? So if you've never seen this graph before and whatnot, the first way to graph this, the easiest way to graph, well, not the easiest, but it is the easiest, but it takes the longest, is to just create a little chart of x points and y points, okay? So this is like x points and y points. You always want to kind of label your graph. So here we're gonna give some points, some stuff around here, right? Actually, I think there is. Is there? Oh, yeah, hell yeah, there we go. Oh, except this thing's not on top now. Ugh, that's annoying. No, screw that. Let's take this off. Can you not remove it? No, don't need that. Okay. Draw a line real quick. Ooh, we got a new mention. Let me see. What's the mention? Yeah, good, good. Yeah, Sora's good. Yeah, make sure you do exclamation point here in the chat so that I know your attendance. Also, if your Twitch username is different than your Discord, it would help me if you could change. Oh, actually, oh, whoa, you can do that too. We can do it in the Discord. Oh.
Wait, you can do it in Discord too now.
Oh, that's dope. Oh, great, actually.
I think it's delayed though. A delay.
Okay. Oh, that's cool. I didn't know. Okay, awesome. Actually, great. Yeah, if you guys can do it in the Discord or in the chat, either works. If your username is different, try to make your Discord name, at least in my server, make it the same as your Twitch username. Nice. Okay, great. Yeah, good job, Sor, dude. Sor's really been an awesome student. He's gone above and beyond in like helping me work out all the kinks in getting this to work. But okay, great. All right. So let's see. All right. Okay, yeah, if it's a letter or two off, it's okay. Like, that's fine. I can understand that. It's just like we had someone who was like Blaze 24/7, and I'm like, I don't see any Blaze 24/7 in my Discord. But that works too. Good. Yeah, Sor's been really he's been a huge help. Like lots of applause to Sor for helping me get all the kinks worked out in doing this. Okay. So, we have our graph that we're going to try to, put on this. Oh, Blaze. Okay, yo, Blaze. Yeah, dude, Blaze, what's your Discord, dude? What's your Discord name, man? I need to know what your Discord name is so I can give you points, because I needed to give you points for the last one, too. let me chat him real quick. Sure, your pawn coins for attending. Oh, nice. And we're at 33 followers. Oh, awesome. Close. 66% of the way to 50. Nice. Yeah, if any of you guys aren't following, make sure you follow the Twitch, too, so that it records your bond coins. And that also helps me get this out to more people. Yeah, big improvement, Sor. Okay. All right, so let's go back. Let's go back to this. So we have f of x is equal to the cube root of x. Okay? So what we're going to do is we're going to just pick some points. So a good point to always pick first is just 0, for instance. So does anyone know what the cube root of 0 is?
But
Good, Neko, 0. Okay, nice. Actually, this is great. Yes. If you all could chat your answers in the Discord chat, yeah, that's a lot faster than. Okay, perfect. Awesome. Okay, great. We figured that out. Yes. Yes, it is 0. All right, awesome. Good. So this is just going to be 0. All right. So now let's say I want to look at what it is for 1. What would the cube root of 1 be? 1. Good. Very good. And then we could go even higher. Let's see. What about 8? Yes, Neko, I do go over Neko, if you have any physics questions, post them here in that Discord channel, and then we'll go over them after this. I have a PhD in physics, so physics is actually my main thing, but I'm also pretty good at math. Yeah, Danny Yoshi, we're still on just graphing things. Okay, so we're looking at the cube root of 8. So let's remember, guys, cube root of 8 is asking yourself what times what times what is equal to 8. And I think T-Bone got it right here, and that answer is 2, right? 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8. So good, this is equal to 2. So now we can start graphing some points here, okay? So we have 0, 0. That's 1, right? We have 1, 1. And then we have 8, 2, right? So 1, 2, 3, 4, 5, 6, 7, 8. We got to go up 2, so it's like right here. Okay. Yeah, exactly. Yeah, dude. If you have any questions and I'm not here, Senpai Sor is the class leader, and so I gave him all permissions to help you guys out. He's sometimes online when I'm not, because I teach other students as well in other ways. So I'm sometimes not always here. Okay, so here now let's get let's do something a little trickier though. Okay. Do you guys know what the cube root of -1 is? Good. T-Bone has it right. Yeah, it's -1. So here, let me show you why that works for you guys. So the cube root of -1 is asking again, what times itself is equal to -1? And in this case, it's -1 because -1 times -1. Okay, let's make this a little bit there. This is equal to 1. So two negatives, when you multiply two negatives together, you get a positive, okay? But then we got to multiply it by another one, which is a -1. And so 1 times -1, a positive times a negative is a negative. So that's why this is equal to -1. You can also kind of just remember, anytime you see the cube root of a negative number, this is actually what these are called. These are called odd functions. So whenever this number here is odd, you can just do it as a regular root, but then put a -1 on it. Okay, yeah, Danny Yoshi, how do we get the negative number? Yeah. So Danny Yoshi, so what we did is we asked ourselves, what times what gives us -1? And it turns out that -1 times -1 gets you 1, times another -1 gets you -1. So that means the answer is -1. Let me know if that makes sense. I can also go over it in like a different way, to make sure that you guys understand it. Okay. Oh, let me move this mic. That's a lot of ones. Yeah, dude. All number ones, dude. Dubs on dubs. Okay. All right. So knowing that, okay, what do you guys think it would be if it was -8? What if we asked for the cube root of -8? -2. Good. Okay, so Danny Yoshi here. Let me show you real quick. All right. Let's say we have the cube root of -8, okay? Remember that cubed root means I'm asking myself what times what times what. Yo, good job, Vibes, dude. Yeah, nice. Is equal to -8. Okay? So, okay. Ooh, whoa, yes, you got pulleys, dude? Oh, yeah, dude, I love pulleys. We're doing your question next for sure, Neko. Yeah, I got you, dude. So Danny Yoshi, we're asking ourselves, what times itself 3 times is going to give me -8? So you know that if we wanted this to be +8, right, from before, this would just be 2, right? Because 2 times 2 times 2 is equal to 8. But I need this to equal -8. So a thing you can try is you can say, okay, what if I made this 2 negative, for instance? Exactly. Good, Danny Yoshi. Yes. So -2 times -2 times -2. This is +4, right? And then we have +4 times -2, because this comes down. This is equal to -8, okay? So that's why this answer is going to be -2. All right, great. So now we have this. Now we can graph what the other side of it looks like, which -1 is -1. And -8 is going to be, so that's, 1, 2, 3, 4, 5, 6, 7, 8 is going to be -2, okay? So if we were to draw a line through this function, it's going to look something like this, okay? That's what this function is, okay? Yes, good, exactly. If the number you need to find is negative, and so Sora, this is specific to it being a root where this number is odd, okay? See how this is 3? If for instance we asked for the square root of -8, that's asking what times itself twice, right, is equal to -8. Does anyone know what the square root of -8 is? What times itself equals -8? It's kind of a trick question.
Is it 1?
No. Oh, good. Neko has it right. It's something times I, which we'll get into that. These are called imaginary numbers. So I actually, and I did this wrong. I shouldn't have done -8. Let's do 9, for instance. That's a better number. So you guys know. So again, the 2 thing means what times itself twice. Equals -9. So 3 times 3, right? That's equal to 9. So you're like, okay, let's try the -1. -3 times -3. but that's also equal to 9 because two negative numbers multiplied by each other is 9. So this does not equal -9, right? So it turns out that neither of these are right. 3 times negative. Yes, you're right. 3 times -3 would be right. But what this whole square root thing says that they need to be the same number. So, Nick, they have to be the same number. 3 and -3 are different numbers. Yeah, exactly. Yeah, that's not correct. Yeah, exactly. So it turns out, and we'll get to this later. This is a more advanced thing. The technical answer for this is 3i. But for your point of view, just say this is like does not exist. It's actually technically what they call it. It's imaginary. It's an imaginary number. Okay, awesome. All right. Yes, yeah, right, Michael. You're right. The 2 is redundant, but we were just going over what cubed roots are. You're right. Most times when they instead of writing the 2, they're just going to write a radical. But this is I'm putting the 2 there to show how like a cube root and whatnot works. Okay. So getting real quick to the end of T-Bone or Knuckles' question here. All right. So now they want us to compare this graph, which looks different to this one. So can anyone tell me what's the difference between this graph and this graph? Good. It's got the +1 here. Very good, Nick. And it's negative. Yes. Okay. Good. Yeah, Neko, dude. Neko, you're the Neko knows this, dude. But yeah. Okay. For those that I'm teaching that don't know this, this +1. So Neko, actually, yeah. What does that +1 mean? Which way is this thing going? Good to the left one. So if we remember, guys, from the Wednesday lesson that we went over, remember when we had a graph that looked like this, and then we said, okay, let's compare it to a different graph, and anything that's very close to the x here, that's adding and subtracting, that moves it to the left and to the right, and then anything outside of it, that moves it up and down. Yeah, dude, nice, dude. Yeah, dude, yeah, dope. Yeah, Nick, yeah, please, dude, please come to every class, man. I guarantee you guys will learn something. If anything, you know, like there's always something, even if you've gone over this, to see it in a different viewpoint. You may pick up on something like you're like, oh wait, I didn't actually understand that when it was explained to me. It's like watching a TV show again. You know, I go back sometimes and watch The Sopranos, and I'm like, oh man, like I didn't notice that. You know, maybe the same with like Attack on Titan or something. So yeah, good. This +1 here, right? So remember, if there's any adding or subtracting very close to the x, that's going to move things to the left and the right. And what actually happens is if things move to the left, they're going to have a plus sign, and if they move to the right, they're going to have a minus sign. So since this is a minus sign, that means it's going to move to the left. So the first thing we would do is we would move this whole graph. Let's see, can I copy it? Yeah, there we go. I would move this whole graph to the left by 1 unit. So you see, guys, how it goes from here and it goes to here? This would be moving at 1, okay? But now there's an additional thing that happens, which is there's a minus sign being multiplied outside of it, okay? And we didn't go over this in the last class. Well, we kind of went over this. We went over what happens, for instance, when you have multipliers outside. So what multipliers do is they stretch it up and down. And we were really just doing numbers. Yeah, it's okay, Danny Yoshi. Yeah. I also record all of these sessions. So if there's ever something you're like, ooh, I want to see what he was talking about, that you can watch the YouTube recording, or you can ask it in another office hours. I'm happy to go over things again, but to make sure I have time to go through everyone's questions, we'll try and do as many of these as we'll try to move forward as much as possible. So what it turns out, guys, is when you have a minus sign out here, what that does is that flips it this way, okay? It flips it over what we call the x-axis. So this graph is, first off, it's going to move to the left by 1. So this would be being 1. And then what it's going to do is it's going to be flipped. So flipping is like kind of like a mirror image type thing. So what this is going to look like is it's going to look something like this. So again, in this case, we moved it back 1 to the left 1, and then we flipped it over the x-axis. Yes, good. Yeah, the whole thing is going to be negative. Yeah. Well, this part will be negative. This part will be positive now because this part was negative, Nick, to begin with, and now it's positive. So, anyways, yeah, that's how we get. That's how you can figure out what a function looks like compared to a parent function. So, very good question there, T-Bone Knuckles. Thank you for asking that. You'll get an additional bond coin for asking the question. And then here, Neko's got a couple questions here. Let's see. You got a couple ones. Here, let me make sure I get T-Bone in for asking the first question. Ooh, nice T-Bone, and T-Bone hit 10 points, dude. So T-Bone, you can after class, or you can do it now, but I won't be able to give it to you yet. But you can redeem that for 1,100 COD points in the prize room. Okay, Neko, which one do you want to do? Do you want to do the pulley system or the inertia one?
I'm having more trouble with inertia.
Okay, cool. Let's pull this in. Why can't I do the... Come on. Windows. There we go. Okay. This is cool. This is physics. All right. A merry-go-round. Okay. With a rotational inertia around its center, spins around its center, blah, blah, blah. Okay, cool. Is I not... Yeah, okay. Okay, so here's a... This is... So again, this may be advanced for a couple people in the chat, but you know, you might get something out of this. This is physics. So for most of you guys, I think you take this probably in your junior year of high school. So Neko, what you've done stuff with linear momentum, right?
Yeah.
So what do you know about linear momentum?
Momentum's always conserved.
Good, very
and
good.
then it's just like M1 B1 is
Good,
plus
good,
M2
exactly.
B2 is
Right, good.
Yeah.
Yeah, linear momentum, right? Which we call P, right?
Yeah.
This is always conserved unless there is a non-conservative force, okay? So what that basically means is anytime you have a system before and after, and as long as there isn't something like blowing up or something like pushing something or adding like more stuff into what's happening, momentum will always be conserved, all right? The same thing holds for angular momentum. So angular momentum, which is, I believe you guys call this L, right? L,
Yeah.
which is equal to R cross P, which is also I omega, right?
yeah.
Yeah. Where this is the moment of inertia, omega is the angular velocity. This is also always conserved as long as there isn't a force, okay? So between these two systems, is there a force that acts on it when this person walks from the outside to the inside?
I don't think so.
You're right.
So
Yeah, good.
That's why I chose A. So.
Yeah, good. Yeah. There is no change in angular momentum because, and with angular momentum, it's not a force that you're worried about. It's actually a torque.
Okay.
So if we remember, so linear stuff, right? You have F equals ma and whatnot.
Yeah.
So linear stuff is going to be torque equals I alpha. So
Yeah.
there are these relationships between linear and angular, and this is how they work. So good. Yeah. So the net torque on this system is 0 because there's nothing like trying to stop this merry-go-round. There's nothing trying to speed it up. The dude's he's just walking inside. So what you have is you have a guy standing out here right at the beginning. And then you have the guy standing closer, right? At the end. Okay. So but the angular momentum always needs to be conserved. So actually, what would be the equate? Let's say this is equal to a mass, and let's say he's located at a distance r0. What would be the equation for the angular momentum here?
Wouldn't it be like MR
Close, very close. It's something with
IW?
yeah. So it's gonna be mv squared over r. Okay.
Okay.
Oh wait, wait,
Is
no,
that
no, no,
because
no, no.
of
Actually,
centripetal
yeah,
acceleration?
yeah. Actually, one second. I have that wrong actually. Is it mv squared over r?
Isn't it L equals MVR?
Yeah, one second. Point mass. See, I can't remember everything. Point
Yeah.
mass, angular momentum. mv squared of r is actually that's centripetal acceleration is what that is. Here, just give me the point. Give me the point. Oh, I is mr. Oh, okay. Actually, I may be right. So this is what it is. Okay. So again, L is equal. I was skipping too many steps. L is equal to I omega, right?
Yeah.
And for a point mass, I is equal to mr squared is what this is.
Okay.
This is mr squared, right? And omega,
Mm.
you can write in terms of v, because if we remember that v is equal to r times omega.
Yeah.
Right? So this is yeah. Right. So omega is going to equal v over r, right? So if I plug that in, I get mr squared times v over r. And so this is going to equal mrv, where v is the linear velocity of it. But again, we actually don't care about the linear velocity because what we're dealing with is the angular velocities, right? The omega.
Should I memorize that the inertia for a point object is mr squared?
Correct.
Or
Yes.
is that given?
That's no, you should memorize that. That's a very common one. That's like F equals ma.
Okay.
You need to know that one. There are some
Alright.
weirder ones, right? So for a sphere, I think it's like 2/5 mr squared or something. They
Yeah.
should give those to you. Are you in AP Physics?
Okay. Yeah.
Yes. They should give you a table of common moments of inertia, but definitely memorize the one for a point mass because that gets used in a lot of other questions.
Thank you.
One quick thing, Neko. You still here?
Yeah.
Okay. So right, we wrote out what the angular momentum would be here. So what's going to happen to this guy spinning if he starts moving closer in?
It decreases.
So what decreases?
The momentum.
But what did we say? What
One-
did we say has to happen?
I mean, wait. So the radius decreases.
Yes.
So so then angular velocity should increase.
Good. Very good.
Maybe.
Yes.
Alright.
Perfect. Right. Because L1, let's say, right, this was mr squared omega, right? L2 is equal to mr squared omega as well, right? But if this goes
Yeah.
down and these two need to equal each other, that means that this must go up. So
Yeah.
this is actually a cool thing. You guys can check this out in your chair. I can't do it because I don't have a big enough office to do this in. But if you're in a chair and you spin and put your arms out, that's like the guy standing on the outside of the merry-go-round. And while you're spinning, try bringing your arms in. And what you'll notice is that you'll start spinning faster. And this has to do with what's called conservation of angular momentum. It's because in order for you to have the same angular momentum as you did with your hands out, when your hands are in, you now need to be rotating faster. So that's a cool way. You can see, this is why I love physics. You can actually see it happen. Like you can try this out at home. Just no one knock over their computer or whatnot trying to do it. Okay, cool. We got nice, dude. Nice, Neko, dude. Awesome. That was a good question. Here, let me-
Wait. So the inertia for a point mass is I equals mv squared over r, or
sorry. So
No.
for point mass, it's MVR is what it is. But really, what it is it's mr squared omega.
okay.
This is the one you should really use. I think a lot of times you guys are gonna just use omega because things are usually moving around in a circle, right?
Yeah.
The only time you need to use this one is because I just worked on a student with. I just helped a student with this actually earlier. Is let's say for instance you have a rod that's like swivels that it can swivel this way, right?
Yeah.
And let's say you have, this is a question they always ask on the AP test. Let's say you have a bullet moving this way, okay?
Yeah.
With a mass and a velocity, okay? Technically, am I a real teacher? I'm an actual teacher, dude, Danny Yoshi.
Oh, nice.
So, technically here, Neko, there is angular momentum in this system, even though this thing is not rotating. And
Yeah.
this
Isn't it the
Mhm.
Sorry.
No, go ahead.
it's the like perpendicular distance from
Very
the
good.
pivot point.
Yes, very
Okay.
good, very good. And this is what the r cross p comes from. So
Okay.
cross always means what is the perpendicular amount between these two vectors at another, lines, right? So this is technically r. Or here, let me use a different color. This is technically r, is what this is, right? And
Yeah.
this is what we're gonna call p, right? Because this p is equal to mv. So r cross p means I need the perpendicular amount of this, which is just this. This is what we call like r perp. So that's why when you're figuring out the angular momentum from this point mass, even though this point mass, right, hasn't hit the thing or whatnot, there is still angular momentum in this whole system. You end up getting, oh well, r perp, right? It is going to be whatever this is, right? Which this is, let's say this is L, and then P is just going to be mv. And a lot of times they actually just call this RMV, or sorry, MVR, where we assume that this is the perpendicular amount of r. So that's where that comes from.
All right. Thank you.
Yeah, for sure, Neko. Awesome, dude.
Nice.
Yo, J-Mac, thanks for the follow, dog. Nice. Okay. All right, so we're gonna end office hours now. Thank you so much, guys, everyone for joining and being here. Let me see. Is Bommy Boy, is Bommy Boy? Are you hosting? So can I raid your stream? So what we do after we go through math and learn some stuff is we hop in the AO and we play some Warzone, dude. We love Warzone. We're gamers. We have a fun time with it. Let me see, where is put a new tab out. Let me do this. Twitch.tv.
Super hesitant, and every bit of advice I got,
what is
as well
this?
as every follower I got from the beginning, was all from your raids and you talking.
What the That's some random guy.
All right. Thank you.
Yes, yeah. Thank you for asking the questions, Neko. I got you your bond coins and whatnot, and if you want to come play with us, hang around. Otherwise, we'll have the next office hours on Wednesday at 4 p.m.
Okay.
Cool.
All right. See you.
Bommy Boy, yeah. Are you hosting your stream, Bommy Boy, dude? Host your stream, dude. Let me raid you. We got like 8 viewers, dude. Yeah, you are trying to become a big streamer. You are a big streamer, dude. Bommy Boy 1 has more followers
Hello.
than I do.
Hello.
Hey, baby, what's up, dude?
Hey, I'm trying to become a big time streamer.
Yeah, are you?
And I want to play.
Okay, nice, nice, dude.
Thank you to all the kids who joined today. I really appreciate it.
Yeah, you guys showing up and learning with us, that really that motivates us.
If I can make a brief request.
Yeah.
Doc. In the common area, we're planning to do a summer camp for all of our students. So if you have any things that you want in the form of prizes and maybe some cool things that you want to do during summer camp or things you want to learn, just let us know.
Yeah, please. So me and Bommy Boy 1 are gonna meet because I know a lot of you guys. You just finished your school and whatnot, so you got all this free time. And we want to make sure that you guys still get to learn a little bit over the summer, but also have some fun with it. So we're gonna come up with some fun summer camp program ideas so that you guys can still earn bond coins and get your COD points and rewards, but also learn some stuff. Keep the brain going. You don't want to come back to school and be like, oh man, I didn't do anything. Oh, now I forget everything. Okay, awesome, T-Bone. Yeah, I will get you your 1100 COD points, dude. Nice. Here, can I raid your channel yet, Bommy Boy?
Ooh, I just went live and we have a few people that have requested to play with us.
Okay, nice, dude. Yeah, maybe we'll split into two quads or something.
That would be cool. Maybe
Yeah.
some custom games.
Do we have 20? We don't have 20 yet, dude. We will get the 20, dude.
Does everybody have Modern Warfare?
Dude, that would be the you don't need Discord, JMac. But it'll help. But we also can use voice chat. That's fine. I still can't see your channel, dude. What?
Yeah, it always takes a little bit of time.
I'll join the stream in a second here.
Yeah.
I need to do something.
Bummy Boy. Come on.
It usually takes a couple minutes.
But yeah, JMac, drop your COD. What is it now? Is it Activision or is it?
Okay, I'm back. What I miss?
What you missed? Sorry, you missed a great session, dude. We had lots of fun people playing.
Okay, I was gone. We were discussing what you have for dinner. Okay,
I was discussing what?
What you have
what you
for
have
dinner?
for dinner?
What did you have for
Sushi,
dinner,
steak, or
dude?
chicken? Okay, those are three tough decisions.
Why not all?
Okay, nice. Here we go. I'm gonna raid you. We're
So
raiding.
so we're gonna have all.
Okay, nice.
Okay. J Mac Queerbait, is that your 1 sec.
Activision?
Okay, I'm getting
Or
on.
is that your PlayStation? I just sent a bunch of requests.
Nice.
I request.
Oh wow. Yo, thank you for
I
the raid,
request
Actual
the roast
Education.
second.
Hello.
Wait, Gio's not gonna be streaming while he plays this time again?
No, I'm hosting his stream.
Well, Gio can stream too.
Yeah, why don't you both do that?
No, it's okay. I actually have to go to PT in like 30 minutes, so I can play maybe 1 or 2 with you guys.
Okay, yeah, same here, because I gotta go to the grocery store after anyways.
Okay, cool.
Wait, how many bunk coins am I getting from this class?
I will add them all up after this. Don't worry. I'll get you guys.
Okay. I'm online.
Okay, nice. Here, I'm gonna hop on.
I'm getting on.
I can stop
We might
streaming
get
right on
hot.
OBS.
Yes.
I'm getting
Yeah.
on. Okay, I'm on.